Hello, my name is Brad Tito. I'm Program Manager for Communities and Local Government at the New York State Energy Research and Development Authority, NYSERDA. On behalf of Governor Cuomo, welcome. This is the LED Street Lighting Academy. This is part 4 of a 4-part webinar series presented by NYSERDA's Clean Energy Communities program and the Lighting Research Center of Rensselaer Polytechnic Institute, the nation's leading center for lighting research and education. The purpose of this academy is to focus on street lighting technology and lighting design to prepare municipal decision makers for interacting with contractors and the public. This webinar is called People First, and we'll be talking about the interaction between lighting and people. Topics covered include color, brightness perception, safety, security, crime prevention, the implications of LED street lighting for human health and well-being, and interaction of LED street lighting and economic development. This seminar will also discuss adaptive street lighting and intelligent connected LED street lighting controls, systems, and strategies. Converting streetlights to energy-efficient LED technology is helping communities across New York to save taxpayer dollars, provide better lighting, reduce energy use, and improve the environment. To date, more than 100 communities across the state have converted hundreds of thousands of streetlights to LED. So if you're considering LED streetlights, it's very likely that a community like yours is already saving money having converted to LED. So for more information, including video and slides from this and the other webinars in the series, please visit NYSERDA's LED Street Lighting Toolkit at nyserda.ny.gov/CEC. You will also find an interactive map where you can find nearby communities that have already converted to LED. NYSERDA's Clean Energy Communities coordinators work on NYSERDA's behalf in every region of the state to provide technical assistance and guidance to help municipalities as they consider next steps with LED streetlights and other high-impact clean energy actions. So just search NYSERDA Clean Energy Communities in your search engine, and you can find all these resources. So we're very happy to introduce Dan Faring of the LRC to kick off People First, Part 4 of the LED Street Lighting Academy. But before I hand it over to Dan, if you have any questions, please use the Q&A box in the webinar. We'll have time to take questions at the end of this call. The webinar is being recorded. Dan?
Thank you, Brad. This is Dan Faring from the Lighting Research Center, and I'm here with Dr. John Bullough, who is our Director of Transportation and Safety Lighting Programs. So as Brad said, this is the last of our 4-part series of webinars, and this one is about people. So we'll talk about really trying to understand the impacts of street lighting on people, as well as some other topics, including the use of controls in LED street lighting. So first of all, the Lighting Research Center, as we said in each of the webinars, we're located in Troy, New York. We're part of RPI. We do research in a lot of different areas, including outdoor lighting, transportation, and safety. But we also do research into human health, human factors, plants, and all different types of areas. The outline for today's webinar, the first thing we're going to talk about is street lighting and safety. We'll go on to talk about crime prevention and economic development. And then we'll talk about what we call the spectral effects of light. So looking at the spectrum of light sources and how that impacts people's perception of brightness and how safe they feel. And then also there is interest in outdoor lighting and health, typically talking about people's circadian rhythms. And so we'll explain that and talk about what that is. And then we'll finish it out talking about adaptive lighting control, or how you can save energy using control of lighting at night, so that you change the amount of light based upon the use of the roadways. So first of all, we're going to talk about street lighting and safety. So I'm going to turn it over to John, and he will start us off there.
All right. Thank you, Dan. So as Dan mentioned, we'll start talking about safety. That is one of the interesting concerns that people have. Often one of the most important concerns is trying to make our cities and towns safer with lighting. And it may seem intuitive that street lighting, must make streets safer, because, a lot of aspects of using streets like walking and driving are highly visual tasks, and of course we need light at night to see. But nighttime is also associated with other safety-related factors as well, such as being tired or fatigued at night, and also things like alcohol or drugs. So while darkness is definitely a less safe time than hours of daylight, we don't necessarily know how much of a role lighting or visibility plays compared to these other factors. One study from the University of Michigan that has some results shown here tried to investigate a role specifically for visibility while holding these other factors like fatigue or intoxication constant, using basically the transitions between standard time and daylight savings time when the clocks change by an hour. So at certain hours around that transition, the clock time would be the same, and it would seem that you'd have the same types of pedestrians and drivers using the road and the sidewalks. Only the overall level of light or dark would differ. And researchers looked at these times and the frequency of different types of crashes that happen during these hours with the same clock time but different overall light levels, and found, especially for pedestrian crashes, the frequency of crashes was much lower in conditions of light than it was in darkness. So assuming that people aren't more likely to be intoxicated or fatigued at these same clock times during that transition, this would suggest that, yes, reduced visibility is definitely an important factor in the higher frequency of accidents that happen at night, and lighting could be a part of the solution to overcome that. Now, it's also helpful to understand what kinds of accidents tend to occur at night and where they occur. And so one very common type of nighttime crash is shown in the diagram on this slide, and it occurs at roadway intersections where two or more streets come together. So a driver who's trying to decide, if and when to enter that intersection might need to judge, where the approaching traffic is, whether there's time to execute a turning maneuver. So they would need to be able to judge how fast those vehicles are moving, how far away they are, and what direction they're going in. And one of the leading causes of crashes at intersections like this is when a driver misjudges that speed, distance, or direction of the approaching vehicle, rolls the dice, presses the gas pedal, and enters the intersection when there wasn't enough time to do so, which results in a crash. So as a thought experiment, imagine that you're at or approaching this intersection at night, and you're trying to decide if you have time to drive into or through the intersection before another vehicle that's also approaching might collide with you. So to make that judgment about how far away it is, how fast it's moving, and in what direction, I think we probably would all agree that we'd rather be looking at the car in the picture on the right, where there's street lighting present. Now, of course, vehicles do have headlights at night, hopefully anyway, and those are highly visible, but only under illumination like the picture on the right, the street lighting, do we have that sort of figure ground information that allows us to better make a judgment about where the vehicle is, how far away it is, and how fast it's moving against the surface of the road. And that will help us make those kinds of judgments more accurately. So visual performance is what we mean when we refer to visibility. And visual performance is defined as the speed and accuracy of visual processing. So how quickly and accurately we can see something depends on several factors, including the overall amount of light. So more light allows the visual system to respond more quickly to an object like a hazard in the field of view. Another factor is the contrast of an object against its immediate background. For example, it's much easier to see a newly painted white crosswalk on brand new dark blacktop than it would be to see a faded crosswalk on old weathered pavement that has grown lighter with age. So the contrast is higher in that former case than it is in the latter. And so the contrast is greater when the white markings, the difference between the light markings and the dark pavement is highest. And that happens, of course, when the markings in the pavement are new. Now, the third factor that influences visual performance is the size of the object that we want to see. When something is closer to us, it spans a larger visual angle in our field of view, and that makes it easier to see the details and identify what exactly it is that we're seeing. And as we move further and further away from that object, it appears smaller and smaller until finally the object itself would disappear when it falls below the limit of our visual acuity. Now, using a model of visibility called the Relative Visual Performance, or RVP model, it's possible to determine how light level, contrast, and size interact to make things like hazards along the street more or less visible. Now, this RVP model was used with state highway intersections in Minnesota that were illuminated according to the state transportation department's lighting design manual. Now, different types of roadway intersections, whether they were in urban or rural areas, and whether they had traffic signals or did not, signalized or unsignalized intersections, were evaluated that have different types of lighting that these intersections would be outfitted with according to Minnesota Department of Transportation's practices. And basically using this RVP model, it was possible to evaluate the incremental increase in visual performance that roadway lighting or street lighting would provide for these intersections using that model. And the table that's shown here at the right shows how much lighting would be expected to improve visibility or visual performance for each type of intersection that was evaluated in this particular study using that RVP model. Now, using data from the Highway Safety Information System, a crash database for each of Minnesota's state roadway intersections, over a several-year period, about 4 years worth of data were collected for all these intersections, both for intersections that had street lighting installed and for ones that did not. And it was possible to determine for each intersection type, whether it was in an urban area or a rural area, whether it was a signalized or unsignalized intersection, how much the presence of lighting influenced the frequency of nighttime crashes. And so what you can see in the table on the right is that in general, most of those numbers are negative, which means lighting was associated with a reduction in nighttime crashes. And that's what we would hope lighting is doing for us at night. And we would expect that. And you might also notice that the reductions in nighttime crashes associated with lighting for rural intersections, if any, are relatively smaller than the safety benefits of lighting for the urban locations. I'd like you to keep that in mind. We'll come back to that thought because it seems perhaps a little bit counterintuitive. Now, if we compare those two different types of analyses, one looking at the crash reductions that are associated with lighting, which are shown here, and then looking at, for the same intersection types, the changes in visibility, the improvements in visibility that we would expect when lighting is present from a visual performance point of view, we can see that there does seem to be a pretty strong correlation for these different intersection types. In other words, when lighting is expected to have the biggest improvement in visibility, it also seems to have the greatest reduction in nighttime crashes. And again, this seems fairly intuitive, right? Lighting helps us see. If we can see better, then we have more opportunity to respond to potential hazards on the road. And while this is intuitive, though, there really isn't very much direct evidence that links visibility to safety. So this study is fairly important in that it does seem to indicate that that link is real and pretty strong. Now, back to this relatively small benefit of lighting that seems to happen in these rural intersections. A lot of the reason seems to be that at rural roads, you have generally faster moving traffic, right? So if you're in a rural area, the vehicles are going to be traveling faster. And when rural intersections are lighted, the most common way to light them is actually to mount a single street light close to the junction of the intersection. So you might have one pole at the intersection that's lighting that particular intersection along what would generally otherwise be unlighted roads. In rural areas, more than 90% of all roads are unlighted. So if the traffic is moving, pretty quickly at say 50 or 60 miles an hour, and we're trying to judge whether an approaching car is going to be going at a proper speed to allow us to cross or enter that intersection, we would really need to have lighting not right at the intersection, but further away, a few hundred feet away from the intersection, so that we could make that judgment about the other approaching vehicle in terms of how fast it's moving, where it's located, and how far from the intersection it is. Because that's really where the figure ground information that we would need to successfully navigate through a rural intersection would be. Having the light right in the middle of the intersection tells us that there's a vehicle going through the intersection, but most likely by the time our vehicle would approach, that vehicle has already gone past and isn't really an issue in terms of safety. So this type of analysis, both from the visibility point of view and from a crash database safety point of view, may give us some insight about how to design better lighting in the future, especially for things like rural roads and streets. So next, we're going to talk a little bit about how lighting might help impact crime and security, as well as economic development. So when it comes to security, one of the key purposes of outdoor lighting, like street lighting, is to help people see what or who is in and around a given area. And lighting should hopefully prevent, mischief makers or worse from hiding in things like alcoves or around corners and behind objects. Lighting should also help us be able to see other people's faces so that we can tell whether if there's a person walking toward us, is that someone we might recognize as a familiar face? Is it a friendly face, or is there someone with a scowl who we might want to perhaps take defensive action or be ready to respond if it's someone who means to do us harm? Now, by doing all these things, we hope that lighting would help deter criminal activity. At least it seems sensible that lighting would help do that. Now, we spoke about recognizing faces, and there have been studies that have looked at, well, how much light do you need to identify a possibly unfamiliar face at different distances away from you? So at a distance of about 15 feet, this is often considered a sort of a critical minimum distance at which someone might want to decide if they would continue walking towards someone or move in a different direction, especially if they're approaching someone they don't recognize or they feel might be threatening to them. So that distance is somewhat of a critical distance before someone starts to enter what you would start to consider your personal space, where you start to have options for what you might want to do. And at this distance of about 15 feet, if you want to make sure that you can recognize faces and perhaps identify, if it's a face that you know, someone you know, a vertical illuminance of about 1 lux, which is about 1/10 of a foot candle, is enough to support, reliable recognition of faces. Now, most street lighting installations will generally give you vertical illuminances of at least 1 lux on the street and on sidewalks. Now, in places where security is perhaps more critical, and it would really be important to see and recognize faces from a greater distance, say from 50 feet away, much further away than 15 feet, then obviously you would need more light. That's because the faces and the details of those faces are smaller when they're seeing them from further away. And we know, as we mentioned when we talked about visual performance, that size is one of those factors that helps drive visual performance. It's easier to see something that's larger in our field of view. So when we're further away, those objects, those faces are smaller. Now, importantly, So from 50 feet away, you would need actually around 30 lux or 3-foot candles of vertical illumination. And many street lighting systems do not typically provide that level of vertical illumination, except perhaps right next to a street light. But in most cases, you're not going to have light levels that are that high from that particular distance. So if that's a concern in certain areas, and some outdoor lighting installations, that may be something that is an objective. You would need to basically look at either higher wattages or specifically look at lighting systems that would provide that type of vertical illumination, hopefully without creating a lot of glare. Now, the last thing I want to mention when we talk about this idea of facial recognition is that the spectrum of the light, and we will talk more about the spectrum, but in terms of recognizing faces, it doesn't seem that the color or the spectrum of the light plays a large role in helping us identify and recognize faces. So in other words, we can do just about as well, say, in a black and white photograph at identifying people than we can in a color photograph. So LED streetlights won't necessarily be better at helping us recognize faces than sodium lights if the light level is about the same. The key is really to make sure you have that amount of vertical illumination that can help do that, regardless of the light source. So far we've been talking in this discussion about security about how lighting obviously helps us see better, and that is important for security. But what we really care about, what really matters are the actual incidences of crime on our streets. That's really what's going to matter in many cases when we're interested in this topic. Does street lighting reduce crime? Well, researchers have been studying this for decades, and that probably gives us a hint right there that the answer may not be as simple as a yes or a no. Here in the U.S., researchers have evaluated different street lighting projects, and in one study, there were 15 different street lighting projects in cities and towns across the country where lighting was either installed or improved in terms of increasing the light levels and spacing and so on. And looking at all these different studies, there was really no significant reliable effect of lighting on the incidence of crime. Unsurprisingly, having better or just lighting in general or improving the lighting did help reduce the fear of crime in people who were using those locations. But again, there was no statistically significant effect on the actual incidence of crime. And that's a finding that seems to show up again and again. So why doesn't street lighting seem to reduce crime when it's installed or improved? Well, part of the issue, again, is that crime is a complicated response to a lot of interacting factors. First, lighting may not always be the only thing that is changed when a city or town decides to do improvements that include street lighting as part of the improvement. There could be other things like physical barriers or additional police patrols that also may obviously have an impact on crime. And in addition, in some studies, it's actually been seen that if one particular neighborhood does have improved lighting, sometimes criminal activity will move to a nearby neighborhood that has poorer lighting. And when you average crime statistics over an area, that may not really capture what's going on at the very localized level. So part of the issue is just the quality of the data that we have to understand what lighting is doing for us or not doing for us. At best, we could say that street lighting is a part of an overall strategy in reducing crime, but it's not going to be a solution in and of itself. There really does need to be citizen participation, increased police patrols. If criminals realize that no one is paying attention and no one's watching them, regardless of the lighting, lighting may simply provide better task lighting for those illegal activities. And in fact, in some studies, improved lighting was associated with increased theft from vehicles, for example. So it actually allows people to see that there might be something worth stealing out of a car and trying to take that. So lighting by itself isn't the solution, but it certainly can be a part of an overall strategy. This other question about economic development is something that also does come up a lot. It's often mentioned as one tool that municipalities can use to spur economic development. And like with crime, there really isn't a lot of direct evidence that would clearly link, the installation or improvement of lighting to increased economic activity in places like urban downtowns. However, there is evidence, for example, that in several studies that pedestrians are more likely to use sidewalks and walkways at night if they're lighted. And the better that they're lighted, the more likely it is that people will tend to use these facilities like sidewalks and so on. And obviously, the first step in economic activity is to get a potential customer to show up. So this is where lighting, might play a role. However, just like this issue with crime, economic activity obviously is much more complicated than, if you light it, they will spend, right? You can't just magically decide that, we put new lighting in, our sidewalks are brighter, and now suddenly that's going to immediately translate into an increase in economic activity. There are a lot of other factors that play into the economic health of a municipality, as I'm sure you know. And it's likely that street lighting is only one of many factors, and probably a relatively minor factor in the big picture. But again, lighting can influence people's willingness to use an outdoor location, to use sidewalks outdoors. And so it does have some role to play, but again, it's not a magic bullet. Now, at the Lighting Research Center, probably most often when people have questions for us about outdoor lighting, about street lighting and these kinds of things, some of the most common questions all come down to this issue of the color or the spectral distribution of street lighting, outdoor lighting, and how it affects people. So let's talk a little bit about some of these spectral effects of street lighting. So these charts show the distribution of spectral energy from a high-pressure sodium and a light-emitting diode light source. And these are the two main contenders for street lighting. The light from each is distributed in different wavelengths, and these wavelengths have different color appearance. So the shorter wavelengths appear violet, blue, and green, and the longer wavelengths appear yellow, orange, and red. So the sodium lamp on the left, you can see, produces most of its energy in the longer wavelengths, giving it its characteristic yellowish appearance. Now, in comparison, most white LEDs will tend to have a narrow, short wavelength peak in the blue part of the spectrum, and that comes from the blue LED chip that white LEDs contain. But you'll also see this broader, long wavelength or yellow emission that comes from the phosphors that are also used in white LEDs, so that mixture of blue and white light appears white. And then by changing the concentration of phosphors, you can actually change the relative heights of those two components and create either a warmer white LED or a cooler white LED, depending on the relative heights and width of those blue and yellow peaks in that spectrum. But in general, you'll see that overall there's a more uniform mixture of wavelengths across the visible spectrum, from blue to green to yellow and red in the white LED than you have from the yellowish sodium light. And so the LED light sources will tend to look white. Now, those differences in spectral distribution can impact how we see at night, how well we see at night. At nighttime, our vision is controlled by a mixture of receptors in our eye called rods and cones. And during the daytime, our eyes rely mainly on cone receptors to see. And the standard definition of light in terms of things like lumens and candelas, foot candles, and lux are all based on the responses of these cone receptors to light. But again, as I mentioned, at night we see with a mix of both rods and cones that are in our eye. And rods are relatively more sensitive to shorter wavelengths than cones are. So a light source with more shorter wavelengths will actually be better for seeing than one with only longer wavelengths, like sodium at night. So even if the light level that we measure with our light meters is the same, because that light meter's response is based on the response of the cones in our eye, it won't necessarily tell us that we can see better, but our eyes will tell us that we can see better in terms of responding to objects, especially objects in the periphery. There are no rods in the central part of the retina, though, so this is interesting that when we're looking right at an object, the benefit of a shorter wavelength light or this bluer wavelength isn't there for sort of on-axis tasks when we're reading license plates or identifying fine details. And this showed up in a study that we did looking at simulated driving performance. Now, driving speed, which is shown on the chart on the top right, under both a sodium light and a white light source, in this case it's metal halide with a spectrum similar to an LED. Driving speed in this study was mainly a matter of keeping the car on the road and avoiding, running off the edge of the road and so on. And that benefit, those are primarily on-axis visual tasks. And as we mentioned, since there are no rods in the middle of our retina in our eye, basically what you see is higher light levels result in higher speeds in this driving study. But there's really no difference between the sodium and the white light source. However, when we looked at detecting an object in peripheral vision, so while people were doing this driving study, occasionally an object would appear 10 or 20 degrees off axis, something that might be an object they would collide into, either a pedestrian or some other kind of object. And we found that as the light level increased, people had fewer misses. So you see in the chart at the bottom right, those curves go down as the light level increases, which means there are fewer misses. People are seeing the object more. But you do see a very strong difference between the yellowish light from sodium and the white light from a metal halide, with fewer misses under the white light. So there does seem to be an advantage for peripheral vision, for hazard detection in our off-axis vision at these low levels that we experience under street lighting, when both our rods and our cones are providing vision. Again, even though our light meter may say they both have the same light level, for detecting things in our off-axis vision, that shorter wavelength light actually will have a benefit. Another area where the spectrum or color of LED light might be advantageous over sodium lighting is in the task of color identification. And this is somewhat related to the issue of security. So if and when a crime does occur, witness reports often include descriptions of the color of clothing and other objects. And under a white light source, like an LED street lighting source, the Lighting Research Center has done a number of studies and found that our ability to identify colors like those of the aprons you see the people in these pictures wearing, performance of identifying those colors was better under a white light source like LED than it was under sodium lighting. Now, the last couple of slides in this section are going to focus not on things that are necessarily beneficial, but things that might potentially be in areas where the spectrum of an LED might have some drawbacks. And one of those is the area of discomfort glare, that annoying or even painful sensation we experience when there's a bright light in the field of view. Now, many of us have experienced this kind of discomfort glare when we see oncoming headlights that use xenon or LED sources that appear much bluer or whiter than older halogen sources, which seem to have a yellowish white appearance. LED streetlights commonly use correlated color temperatures, or CCTs, of 3,000 or 4,000 Kelvin, which ranges from what we might consider warm white to about neutral white. In comparison, high-pressure sodium lamps have a CCT of around 2,100 Kelvin, which is quite a bit lower. So higher CCT means the source will tend to have more shorter wavelengths or blue spectral output, and that means it's more likely to create more visual discomfort. We do seem to respond to shorter wavelengths as when there is a bright light in our field of view as being more uncomfortable. The chart on this slide shows how an LED with a high CCT results in lower visual comfort ratings than another LED with a lower CCT. So it is important when we're installing LED street lighting to try to make sure that pedestrians and drivers don't have a direct view of the LED source. And controlling for glare is something that's especially important for LED street lighting. Another area of concern when it comes to LED street lighting is the possibility that these lights can disturb our body's circadian rhythms, our ability to sleep at night. And the human circadian system is in general somewhat more sensitive to shorter wavelengths. The sky is blue, and that's obviously one of the first light sources that we've experienced in human history. And it does seem that the circadian system has sort of tuned its spectral sensitivity to that. Because of this, organizations like the American Medical Association have suggested that LED street lighting should use correlated color temperatures that are no higher than 3,000 kelvins, again, which is a warm white sort of color. Now, you can get a much more detailed discussion of this issue at the YouTube link that's shown here or the QR code. But there are two factors that I want to consider for this morning. And one is the absolute light level that street lighting produces at night. And the other is related exactly to how the circadian system processes color information from different light sources. So if we take a typical street light that's mounted on a pole and measure the illuminance from that light at our eyes as we're walking toward the street light, say along the sidewalk, the curves on this chart show what the illuminance at our eyes would be for different distances from the street light, either if we're looking straight ahead, which is probably more likely what we would be doing if we're walking down the sidewalk at night, or if we tilted our head up to look directly at the street light. And what you can see is that at most distances from the street light, up to about 20 feet away, the illuminance from the street light will be less than 18 lux, or just a little under 2 foot candles at our eyes. It's only as we get even closer, like 10 feet away, where the illuminance would exceed 20 lux or approach 100 lux if we happen to be looking straight up into the street light. So fortunately for the response of disrupting our circadian rhythms, the circadian system requires relatively long exposures of light, at least about a half an hour, to have much of an impact. And if people aren't going to be standing under streetlights and looking up into them for that amount of time, it's not likely they would be exposed to much more than about 18 lux over, say, an extended period of time outdoors on a lighted street. So taking into account the absolute response of the human circadian system to light, measured by responses like melatonin suppression, which is the hormone our bodies produce at night, we can see on this chart that 18 lux of light from a sodium street light for an exposure duration of an hour will have essentially a negligible impact. You see it's all the way down at the bottom of that curve where it's really having essentially not even a measurable impact on melatonin suppression. Now, of course, LED lights will have greater short wavelength energy, and in general that will increase their relative effectiveness for the circadian system. But you can see that as long as the illuminance remains around this value of 18 lux or so, that even the white LED sources will have relatively small impacts on melatonin suppression. It's really only when you get light levels that are higher, like the ones we experience indoors during the daytime or outdoors during the daytime, that you begin to have these large impacts on the circadian system. Now, interestingly, in studies of melatonin suppression, we found that many LED sources that have a color temperature of 4,000 kelvins actually tend to have a smaller impact on the circadian system than many 3,000 Kelvin LED sources. And again, this is because, as I mentioned, the circadian system does seem to have some kind of vestige of what we might call color vision. And a 3000 Kelvin LED actually contains more color than, say, a 4000 Kelvin LED, which appears, white and colorless. At any rate, the relative impacts of all these different sources when they produce typical street lighting levels are generally not high enough to really have a measurable impact on the circadian system in most people under most situations. And I just want to before I turn things over back to Dan, just point out that because of this strange but interesting issue with the potential for color vision, it's clear that correlated color temperature, or CCT, really isn't an appropriate metric for things like the circadian system. Here's a chart that shows you some data on how melatonin was suppressed after an hour of exposure to lights varying in their CCT. And again, we see that a source with a CCT near 4,000 kelvins actually has less of an impact than one with 3,000 kelvins. And of course, the illuminances in those studies are several hundreds of lux at the eyes for an hour, and not 18 lux like we would expect from a lot of street lighting installations. So the Lighting Research Center has been working on developing a metric called circadian stimulus to try to understand how the spectrum and the light level all interact for these circadian effects. And there is a calculator online shown at the link at the bottom where people can actually evaluate the circadian impacts of any arbitrary light source at any level. So what I'd like to do now is turn things back over to Dan Frering, and he's going to briefly share some information about adaptive street lighting control.
Thanks, John. So adaptive street lighting control is simply looking at the use of roadways and different areas at night and adjusting the light levels based upon activity and so on. So for example, if you look at most roadways at night, they're used heavily in the early evening. So people are going home from work, or they're out shopping, or whatever they're doing, and they're using the roadways in the evening. But once you get past midnight or so, those roadways are not used very much, and then that use tends to increase as you approach early morning. So especially at this time of year, where you might be out in your car at 6 or 7 o'clock in the morning, it's still dark, and you're using the roadway again. So knowing this, and most municipalities have information on what their traffic use is, should street lighting really be constant throughout the night, throughout the nighttime? And a lot of people are thinking about this. Even the IES, when they, the Illuminating Engineering Society, which sets recommendations for light levels, when they revised their light level recommendations in 2018, they came up with a system that says if your street type changes, so when we think about street types, street classifications, we think of them as major roads, collector roads, and local roads. And major roads are things like highways where the speeds are high, and collector roads, a little less traffic, and local roads, very little traffic at night. If your traffic level decreases as the nighttime goes along, as we saw in the chart on the previous slide, typically it will, you can actually lower your light levels. So the recommendations go down because the traffic on this road goes down. So there'll be less conflict with other cars, with pedestrians. And so you can follow the recommended practice and lower your light levels on these streets. So basically what we find in our research is that light levels, higher light levels, so your maximum light level on your roadway, will be very beneficial when the traffic is high. But when the traffic and use of the roadway is lower, it makes sense to, in fact, lower those light levels. So this can be accomplished in a number of ways. And when we think about adaptive lighting or control, we always think simplest is best, so most simple. So what's the most simple way to do this? Well, the most simple way to do it would be to have a time clock of some kind attached to the circuit of your street lights and say, okay, we know that generally after, let's say, 11 p.m. or midnight, or depending on the type of road, we know that there's going to be significantly less traffic. you could simply say, okay, I'm going to reduce that lighting by 30%, let's say. 30% will have a negligible impact on visibility, yet it would save, that much energy. If we reduce light levels with LED systems, then typically the energy savings for that reduction is commensurate with the percentage. And we can do that for those hours of little use, and then the time clock could bring that level up, and then turn the lights off when it's light enough again that we don't need lighting. The other thing could be a motion sensor. Now on street lights, motion sensors are a little more difficult. So you can imagine, for example, an intersection of a street where someone is entering the street. You could mount a motion sensor on the entrance of that street, which would then bring up the light on that entire street as people are using it. And then when that sensor senses that no one else is entering that street over a period of time, it could bring the light levels back down. Motion sensors that are mounted directly on the light fixtures, which are used often in parking lots at night, will not work well for street lights, because you don't want the light to, the car would have to approach too close to the street light to bring the light levels up, and especially at higher speeds, that car would basically pass that street light before the light levels really came up. So motion sensors are a little more difficult on streets unless they're small private streets where you can do that. So either you're accomplishing this with a time clock if you want to be simple, or as NYPA presented in the last seminar, there are smart, I hate to use that word, but that's the word most people use. There are smart systems or connected control systems that allow you to adjust your light levels over time based upon traffic volume. And if you have one of those systems in your city or town, you can be, you can make those adjustments, and it can monitor traffic, and it can do this in real time. And that becomes very complex, though. So I don't know that in most cases that is useful. It might be in very high traffic areas in very large cities, but in most cases, a simple thing like a time clock is probably what you want to use. Now, in parking lots, motion sensors work very, very well. So as a municipality, you not only light streets, but you also light parking areas at night. We have found that motion sensor systems in parking lots are very acceptable, that you can often dim the lights down as much as 70% or more when no motion is detected, and people still think that that parking lot looks safe. They have no problem entering it, and the lights typically will come up. These motion sensors work relatively well, better for cars than for pedestrians. Pedestrian has to get a little bit closer to the light fixture before it goes up, but they do work well. So think about that. Think about adaptive lighting and how you might put that in as a strategy, because LEDs are unique. With high pressure sodium, it was very difficult to dim the lights. They could only be dimmed a small portion before they would extinguish. It's much easier to do that with LED systems. Most of them are dimmable and can be set to dim any percentage. You could dim them 30%, 50%, 70%, whatever you feel comfortable with while maintaining safety on that roadway. So I do want to end by saying that we do still have technical assistance available for municipalities. We've helped a number of municipalities with various questions. So if you do have some questions that you have, or you do want assistance, you can contact your Clean Energy Communities Coordinator. That would be your first step, and they'll put you in contact with us here at the LRC, and we can provide this assistance to you. So keep that in mind if you are still planning or considering replacing your streetlights. And this can be either if you're continuing to go with your utility provider, or if you're purchasing your streetlights yourself. So this assistance can be given to you in either instance. So I'm going to turn it back over to Brad, and he's going to let us see if there are any questions.
Great, thanks. So we're going to go into the Q&A section of this webinar now. If you have any questions, please feel free to use the Q&A box. We do have a few here. So communities with a lot of outlights, okay, or old, outdated street lighting equipment, can really look terrible, frankly. But communities with new LED street lighting appear more vibrant and attractive. This may also be true about communities with streetscaping, parks, or other amenities, but you're saying there's no direct evidence of a relationship between lighting and economic development?
That's right. In terms of just having the data that show when lighting itself was installed, that economic activity increased. Again, it's probably part of a logical chain, but it's also one of those things that may be somewhat difficult to isolate just lighting from perhaps other things like having a business improvement district sweeping the streets and greeting people and things like that, or having markers for wayfinding. All those things often happen at the same time, so it's difficult to isolate and therefore establish, yes, lighting is gonna make this difference. It's probably a piece of the strategy, but there just isn't the data that establish it.
This is often thought of as, when you look at research, the difference between correlation and causation. So there is probably a correlation between improved street lighting and economic development. Those things correlate, but it's difficult to say that the improved street lighting causes the improvement in economic development.
Now, is there a way to quantify the benefits of adding streetlights in rural areas in terms of avoiding accidents? And is it reasonable to say that these benefits can help offset the costs of adding new lights?
Yes. The short answer is yes. Obviously, when you're talking about rural intersection lighting, that's obviously largely a safety issue. And whether it makes sense or not, the federal government has essentially assigned a dollar value to our lives in terms of a fatal crash or even an injury or property damage. And so, again, there is an economic value of avoiding a crash, right, that you don't have those economic losses. And many agencies will use that economic value as the justification to say, okay, the lighting system may have a certain cost, but it's going to have a benefit in avoiding crashes, which could be on the order of hundreds of thousands or millions of dollars if it's a fatal crash that's being avoided. So there are ways that try to essentially determine those costs and the benefits and weigh those to make sure that lighting is going to have a net benefit for the cost of the equipment and the energy. And so there is a process for doing that. The good news with lighting is that it's even accounting for some of the cost of if you had to install a pole, if you are expecting any kind of traffic to go through this rural intersection, even though crashes are going to be fairly infrequent, the likelihood of avoiding even a small number of crashes over a long period of time would tend to make lighting economically feasible. Now, of course, no one mails a check to a municipality for thousands or hundreds of thousands of dollars because crashes were avoided. So no one actually sees that economic benefit. It's a benefit to society and the public. So that obviously has some challenges for municipal budgeting and those kinds of things.
Now, in terms of quality of light, its warmth, these are important to many communities, and 4000K is perceived as being too bright, while 2700K might be sufficient. Do you have any response or feedback on that difference?
Yes, in fact, that is something that is something we found, that generally the higher color temperatures for the same light level will appear brighter. If it's an area where safety is a concern, that increase in brightness will tend to translate into people thinking it feels perhaps a little bit safer. On the other hand, if you have an urban area with a street cafe where perhaps safety isn't necessarily a primary issue, people might prefer a warmer light for social interaction and things like that. So it's not the only factor that matters. It certainly can give you a little bit of additional leverage. But one of the main issues that's probably worth emphasizing is that the uniformity of light for outdoor lighting can often have a bigger impact than the spectrum. Making it more uniform will make it feel brighter, feel safer, and you don't necessarily have to even use higher light levels. Sometimes a lower light level that's more uniform will appear friendlier or safer than a higher light level that has less uniformity. So that is something to think about, how all those factors interact. But uniformity is something that is often not considered as much in outdoor lighting, especially along streets and so on, that could probably make a big difference, allowing us to use less energy, less light pollution, but maintain good visibility, good visual effectiveness.
Also, I mean, the choice in streetlights typically that municipalities have from most providers, especially if you're sticking with utility, is either 3,000 or 4,000. You rarely will get the choice of 2,700 or lower. And what we found in research we've done is that when you put those side by side and you light some part of the street with 3,000 and some part of the street with 4,000, people cannot tell the difference, that the difference is small enough that they don't really see the difference in the two correlated color temperatures. So you have to get a significant difference for people to even be able to tell what that difference is.
Now, how does a village respond to residents that produce articles that show negative impacts of LED lights, and what is the credibility of these third-party studies?
Well, we'd have to see the actual studies. So, I mean, I think, again, you know, there are some issues where discomfort glare can be higher if the color temperature is higher. So when you're going from essentially a yellowish light from sodium to a whitish light, regardless of the color temperature, you are going to have things where the brightness appears higher. There may be more glare. And so it is important to understand, you know, what you're replacing and what you're replacing it with. Some cases, you know, doing those analyses, doing a mock-up to say, are these particular streetlights going to be seen as glaring? You know, the issues with the circadian system, for the most part, as long as those lights are not producing hundreds of lux at people's eyes, are probably not going to be a problem regardless of the spectrum. But if you have a light right in your window, and you know, maybe there's an exception to the rule where you might get those high light level exposures. But in general, you know, there are some issues where the light is brighter, it does look different, and that may make some people happier and may make some people less happy.
If you're thinking of the health impacts, the nighttime health, so we do have resources available on our website. If you go to the Lighting Research Center's website, we have published information that basically explains a lot of what John has said. You know, and it simply goes down to that streetlights just do not produce enough light at night, no matter what the CCT is or what the spectral composition of those light sources are, to have a negative impact on health. That there has really been no research that credibly shows that street lighting, as designed in the United States, can have a negative impact on health. And that CCT is such a poor measure of spectrum that you can't say that one CCT is better than another. But what you might want to do with citizens that are in your municipality, is to just point them to our website. You know, we are an independent third party, and you know, we've been around for over 30 years, and generally what we say is well respected.
Well, that's all the time we have for questions. We hope you have enjoyed this series. Thank you to Dan Frering and Dr. John Bullough of the Lighting Research Center of the Rensselaer Polytechnic Institute. We'd also like to thank Robert Biederman, who is an Excelsior Fellow working for NYSERDA. Rob did much of the legwork ensuring the success of this series. Again, for more information, including a copy of the slides and a video of the entire LED Street Lighting Academy, or to connect with a Clean Energy Communities Coordinator, please visit www.nyserda.ny.gov/CEC. Thank you for joining, and have a great rest of the day.